I'm going to continue of our xenobiotics discussion, and we're going to continue with the pesticide. Now, pesticide, as you know, is a chemical produced by human, um, usually by synthetic way. Synthetic means it is produced in the lab, man-made. It's not natural, and then they are used in one single purpose, which is to kill whatever that they are invented. So if it's invented to kill insect, it's called insecticide. If it's used to kill fungus, it's called fungicide, as what you can see right there. So most of these pesticide, they are created to control pests. Pest means something that is unwanted. So in this case, most of these pesticide or pests comes from the agricultural sector. Because when you want to mass produce something, it's unavoidable. Nature will have itself, and it is natural that you have some organism that will come and eat away whatever that you grow. And because of that, because of that, it will be a factor in reducing the productivity. Now, imagine like if you grow something, and then without being invited, this so-called organism comes and eat away all your crops. So not only it destroy the crop, it also going to reduce the productivity. And because of that, um, pesticide gains some name. Now, just a bit of history for you. Now, before World War II, before World War II, there's no such thing as pesticide for your information. Well, even if there is, it is not widely used because during that time, the level of research, okay, the chemicals before World War II are not that advanced. People still don't know how to kill people. And after World War II, there are a lot of scientists that has developed um, weapons in World War II. And for your information, some of these weapons were used, and they were used by Japanese, for your information. Some might be used by the Germans, and then it is said that the Americans and the British also have developed similar weapon, chemical weapon to kill people. And fortunately, after World War II, majority of these chemical weapons were not used, fortunately. But here's the problem. Now that they have a lot of these so-called weapon, then how are they going to benefit from it? Because a lot of money have already invested to find these so-called new compounds to kill people. And then what happened after that? The US government, for information, through a company, they have developed so many of these compounds, so many of these toxic compounds, and they say, why not use it for the civilians? And during that time, in United States, once the soldiers returned from the war, they were given a land so that they can become a farmer. Because of course, after they went to war, what else can they do? They cannot kill people anymore. So the government of this nation, they gave their soldiers land so that they become farmers later on. So after that, then what again? They just take out whatever they have developed before that and test it to become pesticide. So for your information, pesticide have seen exponential growth and use in 1960s and 70s. In fact, majority of the chemicals are developed during that time. But here's a problem. We have a lot of problem when it comes to a lot of these chemicals. And for information, DDT was developed in the 1970s. And during that time, DDT was developed. They were only known for their killing ability. It kills very effectively insects. Now, here's a problem. During that time, they were marketed and they did not do too much of study regarding its toxic effect to the environment, how long DDT can stay in the environment. They did not. So during that time, they were used in United States to kill a lot of things, and during that time, almost the entire ecosystem has been wiped out. So that is because DDT, they have very low biodegradability. That means it will stay very long in the environment, and whatever that comes in contact dies straight away. They don't, I mean, the organism in the environment don't even have a chance to biologically degrade DDT. So that is how strong it is. And then there's a new group of chemicals, pesticide, is called organophosphate. Now, for information, organophosphate is very famously used nowadays. If you want to know, organic phosphate has been used in two major conflicts. Number one, the Syrian war. If you still remember, there's like a horrible video clips of the civilians in Syria dying due to suffocation. They say they use nerve gas. Kan? That nerve gas, the chemical properties is organophosphate. It's organic. They also have a phosphate group. So when it comes in contact to human skin, it absorbs, and then your muscle virtually cannot move. That includes your lung. So when they cannot draw air, they just suffocate. That's why people in Syria, when it comes in contact with this nerve gas, they die straight. Another example of organophosphate is, if you still remember, there's one murder case in KLIA2, uh, has relation to North Korea. Yeah, same thing, same nerve agent, also come from organophosphate. Carbamates are a group of chemicals previously used as a fungicide, if not mistaken. But nowadays, you have not seen any too much of use because most of the time, carbamates, they are no longer effective, I would say. So majority of the insecticides nowadays, they are either chlorinated hydrocarbon or organophosphate. I think, let me see. Yeah, example, as you can see right here, DDT. It's akin of biphenyl, but it's not really a biphenyl. Biphenyl, in between here, there's no CH, there's no hydrocarbon. But it looks very similar. Okay. Um, Carbamyls, as you can see right there, they have like a group with nitrogen right here, an amine group. It's actually an amide, not really an amide. Amide is whatever I'm circling right here is called amide, and they are attached to. It's very complicated, I would say. Yeah. Organophosphate, as you can see right there, they have phosphate group, and they have majority of them organic groups. So it could be like this one. It could be so many ways. Yeah. Again, if you're feeling too worried about the structure and also the name, relax. I will not going to ask you to give names or maybe even ask you to draw structure so you can all relax lah. But bear in mind why these pesticides are being mentioned here. They have one common criteria. They have one common characteristic, which they are very persistent in the environment. Okay. If it's not persistent, is not an issue. Most of the so-called safe, okay, relatively safe pesticide, when you spray in the environment, they will automatically degrade it within days. These pesticides, as you can see right here, these three, they can stay up to months, maybe years. So that is the issue. They stay too long and they don't degrade fast enough. Okay, so I won't going to talk about this one fungicide because it's not chemistry class, but you know lah, fungicide, they are used to kill fungus. And I think maybe you have used some of these yourself. Like if you see some dark spot in the walls or maybe in your clothes, maybe you want to put some vinegar inside, and vinegar can kill fungus. So yeah, don't use toxic material. If you have fungus anywhere in your house or in your clothes, just put vinegar and it can kill fungicide. It can kill this fungus, yeah. And most of these fungicide, they are either using vinegar. They contain vinegar, but the potent ones, the really strong fungicide, usually contain sulfur, like this one here. Thio means sulfur. Triazole. Azole, they have some that is mixed with other elements. Okay, herbicide. Now, there's a history behind herbicide. Herbicide, majority of them, they are developed during World War II as well as Vietnam War. And you know why Vietnam War is famously used herbicide? Because The United States were against the Viet Cong, okay, the so-called the army from the communist Vietnam. And the United States actually, no matter what kind of movie that you see in the TV, they actually lost Vietnam War. So it's kind of like a shame to them since they won World War II. How can they lose to an Asian countries like Vietnam, very small nation? They lose because what? Because Americans, they're very big, and when they are in the jungle, they cannot tahan all those mosquito bite kan. And then they were up against the very smallly built Asian people. So what they do is when they are up against these so-called Vietnamese people, Vietnam being so small, they can hide anywhere. You just need a bush. They just hide anywhere, and there's no way they can tell. But if you compare with the largely built Americans, they cannot hide because they're too tall or they're too big. Kan? So during that time lah, majority of the wars in Vietnam, the one of the major weapons used by the Americans is herbicide. For information, it's not bombs, it's herbicide. Because first thing before they go into in the front lines to kill those Viet Congs, they will need to know where they are. So they will have to chantas lah. They have to kill all the trees, the plants, whatever that's in their jungle, so that there's nowhere that these Viet Congs can hide. So during Vietnam War, okay, it can be said that majority of those pesticides used are DDT. Apart from DDT, it's called Agent Orange. Now, Agent Orange also is very similar to DDT. They belong to the same group of chemicals. So this is one type of DDT family, 2,4-D. And then the name, as you can see themselves, it could be a lot of things lah. Now, herbicide nowadays, there's recently one that has been banned. 10 years ago, they were marketed, but today it has been banned. Now, for your information, that pesticide is still legally sold in Malaysia. I'm talking about number 3, glyphosate or Roundup. Now, if you, in any chance, encountering this pesticide, please remember, do not buy, and most importantly, do not use. This glyphosate, if you spray to any plants, it will die instantly, like in 1 day or 2 days time. It is that toxic. But here's the problem. When you use it, you also have a higher risk of catching cancer. And for information, Bangladesh lah, Bangladesh kan? Much more poorer than us. Bangladesh have already banned Roundup. Malaysia have not. So you also know lah where we are right now, okay? So these are the herbicide, carbamates, and so on. They are toxic, and majority of the problem is they stay too long. But I think there is another thing that we need to talk about. Okay, example of herbicides. So that's it. Have a look at yourself. I'm going to skip to the important parts, or still not the important parts yet, because still the introduction of this pesticide. So nematocides, as you have learned before, nematodes, worm, tiny little worms. So this worm, previously they are of health concern lah. So sometimes these nematocides can be easily killed by chemicals such as methyl bromide. So methyl, you have CH3 attached to Br. It is very small, and this compound, it can be said quite soluble in water. It is soluble, much more soluble than the compounds that you've seen earlier. And this is the chemical, the same chemical where you have the fumigation. Fumigation is at times, I believe at times when you have your lecture earlier in UITM, during the lecture, there are some people walk into the room and then spray chemical at the corner. They are doing fumigation. So these chemicals can contain methyl bromide. And what does methyl bromide do? They kill semut, they kill insect, they kill cockroaches, and they also prevent lizards from coming in. So again, they are toxic. Now, the problem is, nowadays, fumigants that contain this one, they smell very nice. So you don't know that these chemicals are actually poisoning you. They smell very nice. Comparing to 20 years ago, 20 years ago when the same compound was used as fumigant, this compound smells horrible. Straight away you know. I mean, the pungent smell of methyl bromide. The first thing that I did when I smell this one is I run because the smell is so horrible. But the problem nowadays, it smells sweet. I don't know what they did. Maybe they mixed with some content of fragrance that you don't know. It covers the bad smell of methyl bromide. So here again, next time when you have fumigation or you see a fumigation, first thing first, don't run. Just open the window. If you don't have window, okay lah, you run lah, yeah. Okay, so next one, we are going to talk about the behavior of organic chemicals in the soil. So here, we are going to discuss about how does this organic compound behave in the soil, whether they move away, whether they volatilize, or whatnot. So here's the quite an important thing, lah, because we know the compounds, they are released in the environment, but here's the thing. It will only harm you when this compound comes in contact with your skin or ingested into your body. Then only it causes the damage. So we need to know lah, once they're released into the environment, where does this compound will be located? So to give you a few examples, there are quite a lot, maybe I think 7, yeah. There are 7 ways how these organic chemicals may behave in the soil. So I'm going to begin with the number 1, the obvious one, vaporization. Because just now, as I said, these organic chemicals, they are small. If they are small, they have a large tendency of being able to be vaporized. Because they're so small, the energy required for them to vibrate away is also quite small. So they easily can be vaporized. So that happens in our climate. Because if you look at our climate, it's warm. And majority of these chemicals, actually the boiling point, the temperature where these chemicals can volatilize, also very small. I'm talking about maybe as low as 40 degrees Celsius. Some of them may be higher, maybe 60 degrees Celsius, but here's the thing. When I say boiling point, that means the entire organic compounds will be fully vaporized. So let's say lah, there's one compound. The boiling point is 60 degrees Celsius. What happened to that compound at room temperature? Room temperature is 30 degrees. Majority of this compound, okay, the answer is majority of this compound will stay as it is, but a small portion of this compound will also can be volatilized, just very small portion. And that is the danger. So let's say if you have a soil constantly exposed to sunlight and they are very warm, chances are the gas, I mean the vapors coming from this PAH might also rise up. I mean, you don't have to go too far away. Just go to any motorbike workshop. You go to any motorbike workshop, and then if it's a very warm day, you're going to smell something from the oil inside, isn't it? Now, those are the PAH. It's not the entire pH, but very small concentration. You can smell it. That is one example of vaporization, or in other words, volatilization. This will happen usually due to high temperature, high environmental temperature. And then number 2, it can be absorbed by soil. Now, this is the majority of the component. I would say oils, when they comes in contact with any components of the soil, like it, silt, sand, or clay, the most prominent, majority of this organic compound will be absorbed. And again, if you go to any motorbike workshop, like have you seen their floor? Their floor, if it's a dirty workshop, most of the time when you see their floor, is like having a lot of black colored tar-like cakes, isn't it? This is because the soil particles has been mixed with the oil coming from the motor engine. And if that happens, it's just like whatever that you can see on the road itself. The road itself is the tar. The tar is actually the oil, very similar to it. And when it mixes with the aggregates, the stone, it becomes aggregate, a cake. So majority the so-called organic chemicals, because they are oil-based, they can actually attach itself very well with the soil, with the soil, yeah, and to form the black colored cake. So that is the adsorption. How they form is through adsorption. And moving on to number three, Malaysia also is very known for its high rainfall. And therefore, when there's enough rain to wash away these soil particles, some of these organic chemicals might be leached away. But there's one condition. Not all chemicals can be easily leached away, because only the small ones, yeah, only the small organic chemicals will have a higher tendency for leaching. The big ones such as PAH, PCB, usually they are not so exposed to leaching lah. But here's the problem. If you have a soil particle, remember just now number two, if you have a soil particle suspended in the water and it comes in contact with PCB or PAH, this soil particle may carry this PAH, these organic chemicals. So leaching also may happen only if the soil particle is suspended. But most of the time, like number three happens due to, it happens on the small organic chemicals. Okay, number four, they may undergo chemical reaction within or on the surface of soil. Chemical reactions. Okay, it's a very big definition. Now, what kind of chemical reactions may happen? So we see. Okay, now example of chemical reaction. It could be sunlight. If you have sunlight, it may induce photochemical reaction. Most of the time, the sunlight that you can see contains UV spectrum. UV is very strong, and when UV strikes any parts of the organic chemicals, it may break its bond. So, in other words, this chemical reaction could be started by the UV spectrum in the sunlight. Okay, so that is one, okay, from the sunlight. The other one element that can also cause this chemical reaction is the oxygen in the air. Our atmosphere contains oxygen, and when you have oxygen, you will have oxidation. Okay, so this oxidation is caused by the oxygen in the air, but here's the thing, it can be accelerated by the UV as well. Yeah, so UV in the sunlight not just breaks the bond and destroy organic chemicals, but it also may help initiate photooxidation. Photo means, I mean, the UV component from sunlight, oxidation with oxygen in the air. So number four, I can say that this is probably a good thing, because when you have photooxidation and the destruction of organic contaminants by UV, that means number four is one way to destroy or to reduce the organic contaminants in the environment. Now, the rest of it is just like they move somewhere, they're not destroyed, isn't it? Number four is the destruction of the organic chemicals in the environment, either by sunlight or by oxygen in the air. Okay, so those are chemical reaction. Number five, they may be broken down by soil microorganism. I put one simple word lah. This is called biodegradation. See, degrade, broken down kan, by soil organism, so biodegradation. I'm sure you know what is that lah, so I don't think I need to explain too much. So I move on to the last two. They may wash into streams and rivers in surface runoff. So this is very similar to leaching, but do you know what is the difference? The difference between this one and leaching is, leaching usually involve dissolution of the organic contaminants, which does not happen all the time lah, yeah. But most of these organic contaminants, if they were to migrate, they want to move from point A to point B, in the environment. They are mostly going to happen through number six lah. Because when there is enough volume of runoff, enough volume of surface running runoff, they may also carry a certain amount of particles, soil particles, and these soil particles may have absorbed also the organic contaminants. So I would say that most of the organic contaminants travel or migrate through number six. And then lastly, number seven, they may be taken up by plants or soil animals and move up the food chain. So this is bad. This is probably the worst. Now, of all the behavior from number one to number seven, um, those from number one and number six, they were just moving around the environment. So as long as you don't comes in contact in other ways, it will not going to have any health effects on the environment or yourself. But number seven is probably unavoidable because this one is accumulated. That means when the plants is grown on the contaminated soil, they will absorb some of this compound into its body, into its any parts of the plants. And that is usually the major concern because when it is absorbed by plants and then after that plants, what do? They were consumed by the lower trophic animal like cows. Cows eat the grass, for example, and then when the grass itself contain these organic compounds, they were digested in their stomach, and after that, they don't come out in the feces. Or yeah, some of them may come out in the feces, but the danger is some of these organic contaminants they may be absorbed by the cow itself and stored in the fatty tissues. And here's a problem: we eat cows, kan? That's a problem. This is how, okay, majority of this contamination that we see nowadays today is due to consumption of the feedstock of the feedstock like cows, chicken. But I will have to say the majority of this organic chemical contamination in food chain happens not to cows and chicken, but rather in your seafood. The seafood that you eat, remember the next time when you go to a sushi restaurant or Japanese restaurant that serve almost 99% of seafood, remember one thing. Yeah, I know it's quite delicious kind of Japanese seafood because majority of this Japanese seafood relies on the fat of the seafood, the fish, for example, like salmon. Salmon very fatty, isn't it? But the problem is that is the delicious part. Now here's a problem. It's quite safe to say most of this seafood that you eat, if you can avoid the fatty part. Yeah, what is the fun of eating seafood by avoiding the fatty part? Because there are a lot of studies established nowadays that stating that the risk of consumption of seafood, majority of them lies on the high content of organic contaminants in their fatty tissue. So yeah, if you want to eat seafood next time, try your best, avoid eating its fatty part. Yeah. If you eat the muscle, the flesh, the risk of poisoning is not that as high as consuming the fatty part. Okay, I will explain to you later on why number seven is such a big issue. Now, just now I say to you, it is transferred to plants and then soil animals and then up the food chain. There is one important word here. By moving this, by the movement, in the movement of these contaminants in the food chain is called bioaccumulation. That means it is accumulated. This poison or this toxic organic contaminants is accumulated by organism, like it from plants through animals. Okay, so that is bioaccumulation. Now the bigger issue here is that when it is moving from plants to animals, the higher it goes in the food chain, it also going to increase the concentration, which means that any apex predator means some organism that eats other organism, or usually they're sitting at the top of the food chain, like for example tigers, polar bears. These are the apex predators that accumulates probably a very high content of these organic chemicals. Now, what's the problem? The problem is the moment you eat this apex predator, it is most likely going to cause poisoning due to they already have high concentration of these organic chemicals in their body. When we humans eat, for example, bears, the risk is they might have poisoning, and this is like happens a lot of time in the polar region, the North Pole. North Pole, we have polar bears, and in the early ages, the explorers, they are mostly non-natives. They are not from that part of the world. So they go to polars, and then as you know, how frequent can you find food in polar? So they discover the polar bear, or maybe a seal. They kill that seal and eat their meat. And after that, they got poisoning and die. Because why? These are the apex predators that have hyper accumulated. So this is a keyword that you have to remember. Hyper accumulated organic chemicals from the environment. So number 7, there are two keywords that you have to remember. I think you probably have learned these two keywords before. One is bioaccumulation. Bioaccumulation is any organisms that can absorb a small amount of these contaminants. Hyperaccumulation means they can uh, they can accumulate more than their own body weight. And when there is an instance of increasing the concentration of organic chemicals when you move up the food chain, the name of this phenomena is called uh, bioaccumulation. So I know in this slide you don't have it, but it's important for you to know these two words: bioaccumulation, uh, bioaccumulation, and biomagnification. Sorry, bioaccumulation is one. The second one is biomagnification. So these are the two keywords that is closely associated with behavior number 7. Okay, so this is a diagram. I think I also have talked a lot. So 20 minutes has passed. And so yeah, this diagram actually summarized to you. Okay, once again, this diagram summarized to you how does the organic contaminants move around in the soil by volatilization and so on. Um, so I strongly encourage you to know what exactly are these 7 behaviors, because 7 is a magic word for essay question. So I haven't come to a point where I want to. I think I've created one question, essay question out of this in the final exam. In the final exam. Um, but this is the important thing, yeah. Before I stop for a 5-minute break, let me repeat to you again the behavior of chemicals in soil, not organic, possibly inorganic part, is a question that will appear in your final exam. So since there is no final exam, so you can wait, maybe the test will ask you the same question.